Here's a short checklist of some of the things every developer should know. Let's dive right in. The 12 net factors. We have a whole YouTube video on this. You can go watch it. But if you're a developer in the modern world, you should probably know these and use them every day in making decisions about not only how you code, what patterns you use, but these things also affect your ability to have good DevOps, to have units of deployment that are as decoupled from each other as possible, and so on. You should know S.O.L.I.D. S.O.L.I.D's a really old idea, but every word of it is as true today as it was when it was first written. But you have to look at S.O.L.I.D through the lens of modern development practices and come back to the fundamentals of what it was trying to tell us, which is the single responsibility principle and how that relates to building distributed systems where each deployable unit does one thing and does it really well. The open and close principle. Most object-oriented programming languages do this, and even languages that have alternate types of inheritance mechanisms or are functional languages, you can still leverage the open and close principle, which is to say they can't tamper with the innards of the code you wrote, but you should write code that lets them reuse it in ways you may not have thought of. The Liskov substitution principle speaks not only to passing things by interfaces like in C# or Java, but also this idea that we should program by contract. So if we have components that interact with each other, clearly defining those contracts, and anything that fulfills the contract allows the components to interact, is all part of the idea behind the Liskov substitution principle. And in a lot of ways, Liskov and the interface segregation principle are pretty tightly related. But again, it breaks down the idea of the Liskov substitution principle to also subsume this idea of single responsibility. And then the dependency inversion principle. So dependency injection is now table stakes constructor injection, passing in the dependencies that a class needs and not hard coding them in. There are lots of great frameworks and tools in a whole bunch of different programming languages. So, for example, the Angular framework written in JavaScript makes good use of dependency injection. And again, these make your components more testable. And by focusing on a single principle and doing it well and offering contracts, we not only provide for extension, but we also provide for people to clearly understand what your component does or what it intends to do. Keep it simple. Don't write code because you think you might need it. This is particularly true for adding in layers of abstraction for their own sake. Don't get me wrong. If you have a scenario where your software could be deployed on Windows or on Linux or whatever, you would be remiss if you did not facade your file I/O with an interface that was more business specific. In other words, store a contract, get a contract, delete a contract, and so on, and then have different implementations that were appropriate. And if you do that, then you can swap in an Amazon S3 bucket, or you can use a sys file system on a Windows server or an NFS mount on a SAN. And you're not really going to break the business part of your contract. Notice we use the word contract again. So I don't want to discourage people from making the right levels of abstraction, and in particular encapsulation. But on the flip side, if you go to add something because you think you might need it later, it's probably a mistake. And if you're concerned about that, then you should think about strategies for versioning your contracts and how in doing so, you can be explicit without providing fields or methods that are for the future but not implemented. Now, that's different if you haven't implemented them yet, and you have no intention of shipping that as a working interface. That's not the same thing at all. But if I have a shippable interface and I have extraneous stuff in it, I've probably made a mistake. So the analogy behind being a great coder is the less code you write, the better a coder you are. Now, that's not to say that our code should be so terse as to be unreadable. We certainly don't want to go back to having to write things like we had to in Fortran 4 with, letter, number, variable names, and, no subroutines, no methods, no functions, no interfaces, no abstractions. But we do want to make sure that our code is terse and crisp. And one of the areas that this shows up in a lot of high-level languages is putting error handling sprinkled like pixie dust all the way through your code. The general rubric for that, as an example, is that low-level things should never catch an exception that they cannot handle and correct. So, for example, if you have a data access layer that's, say, written in C# on top of Entity Framework, and you're implementing the poly retry policy layer, well, then yes, poly is going to hook the SQL connectivity type exceptions and implement the policy that you directed it to do retrying for transient connections and so on, exponential back off, things like that. That's a good example because that is a problem your code actually could handle. But if your code is passed in garbage, you should just throw. If your code gets to a place of incomputability, which is a fancy way of saying that what's going on just doesn't make any sense, your code should throw. And throwing the right thing, the useful thing, a consistent thing across your coding and library should be part of your shop standard. But you can get rid of an awful lot of cruft in your code by ripping out the error handling and low-level functions and letting the thing that does the calling decide what to do about it if they call your library method and your library method can't do anything with what they did. So think about that. By the way, Jason Bach has some great presentations on error handling in C#. And there are lots of other great presentations up on YouTube about Java and JavaScript and lots of other languages. So the idea of reusability has been kind of the holy grail of programming for a long time. And we've seen it wax and wane. I think we have reached a point where we now have responsible ways of doing that in ways that are durable and not crazy making. So package managers like NuGet and NPM allow you to consume libraries. And in fact, Microsoft and OpenJava and the PHP community and the Node community all have lush library repositories with peer ratings and the number of downloads as a function of popularity. And because most of them are open source, you can crack them open and look at them. But you're going to get that reusability. In .NET and C#, I love the Newtonsoft JSON libraries. And so I count on them. I depend on them. And I've come to trust them. And so I'm going to get my reusability in terms of modules and functions, because I'm going to consume NuGet packages in my case, or NPM packages if I'm doing Node, that I trust. Web services are another way of getting reusable modules and functions. And so are datagram standards, right? If we look at the standard for HTTP, that is effectively a datagram standard, because HTTP doesn't care what network transport it comes in on. It just says it's going to be a UTF file. It's going to have, these things in it and so on. At a lower level, protocols are reusable models. TCP/IP is a protocol most of us live with every day. And I think it's underappreciated, the genius that went into creating a lot of these reusable things. And of course, the favorite thing for good developers, which is patterns. A warning about patterns, though. Patterns are great, but if all you have in your toolbox is a hammer, everything you see is a nail. So if you're going to be serious about learning patterns, you need to do two things. One is you need to recognize a pattern when you see it. The .NET framework, the Spring framework, are frameworks of patterns that act together in a cohesive way. So if you put patterns on top of their patterns, your patterns should be adding value. Otherwise, you should have used the patterns that were provided for you in the framework. If you find yourself building your own framework, probably, unless you're a framework designer, you've probably done something horrible. So again, when we think about reusability, we want to think about S.O.L.I.D, right? Newtonsoft JSON does one thing. It does really well, and that is it manipulates JSON, allows you to query JSON, build JSON, decompose JSON, but there's this core element of what it does. Microsoft.extensions.logging for .NET Core is this one core idea of mostly contracts that says this is how logging should behave, and so on. Domain-driven design. Eric Evans coined this term, but many of us, when we read his book, we went, wow, we're kind of doing 80% of that, in terms of looking at all the actors and datagrams in our system and their interactions and putting them on a big piece of paper, a big whiteboard, and starting to draw some fences around them that represent the domains, and having clean separation of domains and understanding how the domains interact with each other through contracts. And the idea behind domain-driven design is probably way too complicated to dig into this in this short lecture. But domain-driven design leads to a lot of really good behaviors on your part in building code stacks and building services and building distributed systems and being 12-factor, in leveraging microservices and using queue mediation and so on. So if you haven't read a book on, or watched some videos or read some blogs, domain-driven design is one of those ideas like S.O.L.I.D that's still around, because it fundamentally was right from the word go. Now, you can get way too complicated and get yourself into analysis paralysis by using it, but domain-driven design is a great way to both think about how your system will be composed together and also validate that you've built a system that doesn't have weird cohesion and that you are being solid and you aren't building extra layers of abstraction and so on. So microservices are this extension of that idea. Microservices combine the ideas of domain-driven design, that is to say, we have groups of interactions that serve a single purpose. We obey the S.O.L.I.D principles, so we want to have a single responsibility for this group of service methods and functions. And we want to think about aggregating like services with each other. And just because a service is architected as a microservice doesn't mean it has to be hosted as a microservice. We use microservices as a way of getting clean design, of giving us the option of taking a host that may be hosting 10 or 12 different microservices and teasing them apart as a function of DevOps, as they have differential loads, or something they no longer share enough characteristics that we want to have them on the same host, or we want to expose some of them to trading partners and not others, and so on. So starting from a place where you can have microservices on sort of a shared host, and then start to tease those apart as you need to, that doesn't involve open heart surgery, right? That's just a minor dissection, and that's pretty straightforward to do. And you can generally do that without breaking the contract, because as a general rule, microservices should be locatable or reachable via their own unique set of addressing. And there's lots of ways of tackling that. Great videos on microservices all over YouTube. Evolutionary design. So the one constant is change, right? We know that our software systems are going to have to evolve, but we want to make sure that we do it in a way that's not going to break a lot of china. And if it does have to break an interface or contract, in other words, let's say we have an interface and it's got some interface members that are datagrams, that are things that need to get passed, and we get to this place where, wow, these two fields are now required. What should we do? Well, we should version the microservice to say the V2 microservice, which will have a different address and a different set of contracts, is different than the V1 microservice. And we may deprecate the V1 microservice, or we may let it run side by side for a little while our consumers make the transition. But the point is that the same rules that you can read about in semantic versioning, and you can go see our YouTube video on that, are the same rules that guide evolutionary design, not just of interfaces and services, but of APIs and of database design. And there is a really great book published by O'Reilly on evolutionary database design. And if you are in a role where you are designing the persistence tier of your application, you'd be crazy not to read it. It's a great book. There's also a couple of good books on evolutionary design of APIs and so on. And there's a really great book on frameworks and how those are evolutionary, called the Framework Design Guidelines, that was written about coming up on a decade ago about the design of the .NET framework. And it's not just a polemic about how they designed it, but one of the great things about that book is they allowed a lot of commentary on things they could have done differently or just flat out may have done wrong. And it is a work of greatness by a team that in all humility knew that they had to build something to a timetable, but they were going to make mistakes they would later come to regret. And in a lot of ways, .NET Standard, upon which .NET Core sits, and soon .NET 5, is a reflection of that. You can see the same thinking in a lot of the papers written by the people responsible for the Java language and Java runtime. And the fact that there are breaking changes between older versions of Java and the most modern versions of Java are actually designed to do two things: keep people from repeating things that are not optimal, but also to guarantee that they are future forward. And of course, that when they did that, there is a major version, right? There are release notes that says these things will break. In many cases, there are tools that you can run on your code and say, these things break. The .NET framework and .NET Core tooling will tell you that during the compilation. So DevOps is table stakes. And we have a whole video on modern development that you should go read. And it's going to dig into all these things in loving detail. We even believe in it so much that we have a whole bunch of satellite videos on individual topics. But DevOps is table stakes. If you are building anything more than a hobbyist project, and if you are a professional developer being paid to produce software that delivers business value, then you have a professional obligation, in our opinion, to exercise at least a minimum set of good DevOps. Likewise, it's very hard to understand how the individual parts of your application will perform unless you understand the nines. And here's a table of the nines, and in fact, there's a pretty good article on this in Wikipedia. There are pretty great articles about performance tuning of specific things, Microsoft SQL Server, Oracle, Mongo, etc. And that not only do they speak to the performance, but the performance is a result of having high availability and disaster recovery, and ideally in a big distributed system, having especially the persistence tier be bulletproof. In other words, it runs active across multiple data centers, and as a result of that, each individual component may only be 2 or 3 nines, but in the aggregate, right, our whole system runs a very large number of nines as a consequence. And understanding the combinatoric behavior of how, if every part of your system has no singletons and they're running in a very distributed way, how you can quickly climb up the number of nines until you get systems that are essentially impossible to take down. And if you combine that with modern DevOps like blue-green deploys and rolling deployments and rolling repavements of your infrastructure and so on, you can have systems that simply don't go down as far as the consumers are concerned. So you should understand the nines, what it means when people say it. And here's a little table of, times so that you can kind of wrap your brain around it. But you should also understand that when you're looking at an entire system, that you need to be able to compute the nines on a system-wide level. And the weakest link is your biggest, bestest amount of nines. So getting rid of singletons, making your distributed, making persistence tiers distributed and so on, allow you to climb the nines hill. Notice it falls off precipitously, and in general, 3 nines is the hallmark that a lot of us strive for an individual component. So the other thing is, as developers, is we have to consider the abilities. And if you go out and you Google non-functional requirements list, you will get a million different opinions about what non-functional requirements are. And we did a little exercise and we said, look, our heads will explode if we have to keep track of 70 non-functional requirement categories, right? Is there a way that we can, we Googled our way through it for weeks and weeks and weeks, and we looked at all the projects we'd done, which is a bunch, and we socialized this with our peers and found out about their projects and about what they think about. And at the end of the day, we were able to, admittedly fairly arbitrarily, make 10 high-level abilities that capture all of the non-functional requirements that we could think of. And in some cases, some of the non-functional requirements that you might have learned if you took a black belt course or you took an ITIL course and so forth, cover off more than one of these, and that's okay. But if you can remember these 10, or do what I do and print them out and stick them up in my cube, then you've got a pretty good shot of keeping in mind those things that are likely to be important. And by the way, on any given project or for any given piece of code, these things don't have equal weight, right? You may trade some of these things for others of these things. And then some of these things are in direct opposition to each other in the real world sometimes. But keeping these in mind will make you a better dev. So is the risk triad. The risk triad is the 100,000 foot view of security concerns. And just like we did with the abilities, we were able to boil them down to 10. The industry has managed to boil down security things into 3 big triangles. And underneath each triangle is a metric ton of things that you should care about. But as a developer, if you remember confidentiality, availability, and integrity as you code, as you design, as you architect, you've got a pretty good chance of delivering systems that have reasonable security. And so, this is another one of those slides that I print out along with the S.O.L.I.D slide and everything else and stick it up in my cube just to remind me as I work on, it's really easy to get wrapped up around the axle of a particular coding problem. But then I always go back and I look at it through the lens of S.O.L.I.D and I look at it through the lens of the CAI model and just make sure that I'm covering off, and I look at the abilities at regular intervals and so on. So these are things you should just know as a developer. Thank you for your kind attention, and I'm sure I left a bunch of stuff out.